So I've been working on starting up my off-grid shed again, and I'm thinking I'm going to be buying a 35-watt solar panel pretty soon. And it'd be really nice to have a meter on my batteries all the time, so I can just come in here and I won't have to hook up a multimeter. There'll just be a meter already hooked up. And I'm thinking my newly acquired Heathkit 1500 volt multimeter should be perfect for that. But it doesn't work, so let's take it inside and take it apart. Let's see what's inside here. So here's the multimeter. This is the model MM-1, Multimeter 1. Now this was first made in 1958, I think. And then I think it was discontinued around like 1970 or so. So this is most likely from the 1960s, but it could very well be from the 1950s. And this feels like Bakelite, and how it broke right there, it looks much like Bakelite too. There's 4 screws, so let's take those off. So here we have this, and as you can see here, for some reason somebody's decided to not use this connector here, and instead just soldered a battery directly on there. There's a wire that goes down there through here that connects to that, and that's pretty crappy. And that connects to that. So, no idea what they're trying to do there. So let's test the voltage of this. It's probably totally dead. Looks like it's from like the 1990s or so. Wow, that's actually not all that dead. 0.8 volts. That is dead, but I was thinking a battery that old would be a lot more dead. Oh 0592. I guess that would be May of 1992. Well, this is unfortunate. If I connect these wires directly to the back of the meter, theoretically when I bring the voltage up, it should raise the meter. But it doesn't. So that means that the meter itself is actually broken. I'm not 100% sure what I should be doing. I guess it couldn't hurt to check the continuity of some of the parts. Okay, so the negative wire comes in through here, comes through here, gets transferred through this insulating board, through this little spring that's right here, and now that spring conveys the electricity to the main rotor, the magnet coil inside here. It goes over here, goes through these little coils right here, which I think help to stabilize it or something. And then the power comes back out through this coil, and it comes out to the frame, and the frame is positive. Unfortunately, it looks like maybe a wire got broken inside of here somewhere. If that's the case, then this thing's pretty much junk. So it looks like maybe this part's pretty bad, and that's pretty much the majority of the unit. Oh well. That was kind of interesting. There's the 2554 and 2554. So maybe that's the date somehow. Maybe 1954? Or is that a 3? Don't know. That looks like a 5 to me though. Okay, yeah, it's a 5. Or maybe it's 173 that's the date, like January 73? I don't know. Doesn't really matter that much though. Here's a little bit closer detail of the rest of the mechanism. It's a quite rudimentary unit. That one white thing right there is pretty interesting. Never seen anything like that. Can't tell if it's just a connector, or maybe it's like a resistor or something. Bradley Labs Incorporated. But yeah, there's really not much to this except for switches and resistors. So unfortunately, it looks like this thing isn't fixable. Well, it is fixable. Everything is fixable. But I'm thinking that this just isn't really worth it to get it back to its original operating conditions. So I think I'll put it back on the shelf, and maybe someday in the future, I'll put a different meter in there. I'll keep the same plate over it and stuff like that. But I can turn this into something else. It'd be kind of cool. Make it more interesting. It'd be really neat to make it like a portable waveform generator to go with an oscilloscope. That'd be pretty cool. Or something. But pretty much this is a really nice little kit box thing that will make a great container for some future project. Well, I hope you enjoyed this video, and thanks for watching. See ya!